If you've ever made a pour over, you know the ritual, right? It feels like art. But what if I told you that behind that art, there's some pretty powerful science that can unlock a perfect cup every single time? We're going to move past the guesswork and turn your morning coffee into a repeatable, delicious experiment. Oh, we've all been there. One day your coffee is just perfect, and the next it's, sour. Or maybe it's shockingly bitter. And you're standing there thinking, I use the same beans, the same grinder, what gives? It feels completely random, I know, but it's not. That's right. Your coffee doesn't have a personality, it's not moody. The flavor that ends up in your cup is a direct result of physics. We're talking things like how water flows, its temperature, and how it pulls flavor out of the grounds. It's all just science, and that means it's predictable. And today, we're going to master it. So what are we actually trying to do here? What's the goal? Well, it's pretty simple, really. We're trying to achieve a super precise and even extraction of all those delicious soluble compounds that are locked inside the coffee grounds. Think of it like trying to hit a bullseye on a target. And this is that bullseye. This number, 18 to 22%, is what the coffee world calls the golden range. It means we want to dissolve about 18 to 22% of the coffee's mass into the water. That's the sweet spot, the absolute perfect balance of sweetness, acidity, and body. Now, to hit that golden range, you've got to control a few key variables. It's a total balancing act between things like the temperature of your water, the speed you pour at, and even the resistance that the coffee grounds themselves create. If you get one of these wrong, the whole thing can just fall apart. So, how do we manage this balancing act? Well, it turns out your simple little coffee dripper is actually a tiny physics laboratory. There are 4 invisible forces at play that are governing everything from the exact moment that water hits the coffee grounds. The first one is called hydraulic resistance. You can just think of it as drag or friction. It's how much the bed of coffee grounds fights back against the water trying to flow through it. It's like a traffic jam for water. The more resistance, the slower the traffic, and the longer the water is stuck hanging out with the coffee. And you can see exactly how that plays out here. If you grind your coffee too fine, the little gaps between the particles are tiny. This creates a ton of resistance, slowing the water down so much that you start pulling out those bitter, nasty flavors. That's over-extraction. But if you go too coarse, the water just rushes right through with almost no resistance, and you're left with a weak, sour, under-extracted cup. Okay, next up, flow rate. This one's pretty simple. It's just the speed of your pour. But don't let that fool you. Mastering your flow rate is how you master the rate of extraction itself. A nice, slow, controlled pour gives you pinpoint command over how quickly those flavors are dissolving into the water. Force number 3 is turbulence. This is just the churning and agitation you create when your stream of water hits that coffee bed. Now, a little bit of turbulence is fantastic. It helps get all the grounds wet nice and evenly. But too much? It's a disaster. It can literally carve channels through the coffee that let water bypass the grounds completely. And finally, we have thermodynamics, which is really just a fancy way of talking about temperature. The sweet spot is right between 92 and 96 degrees Celsius. Hotter water dissolves things faster, but if you go too high, you start extracting all that bitterness. Too low, and you'll get a sour, underdeveloped brew. Temperature even changes how thick or thin the water is, its viscosity, which affects how fast it flows. All right, so we've covered the forces. Now let's apply them to a step that a lot of people think is just for show, but is actually one of the most important parts, the bloom. This is not just some pretty ritual, folks. It is a critical gas management step. Here's a wild fact for you. Freshly roasted coffee can be up to 2% carbon dioxide by weight. That is a lot of gas trapped inside those little beans, just waiting to get out. And the second you add hot water, poof, it escapes like crazy. Now here's why that matters. That escaping CO2 gas acts like a hydrophobic or water-repelling force field. I'm not kidding. It literally pushes water away from the coffee particles. This creates all these little dry pockets inside the coffee bed and makes an even extraction basically impossible. If you don't deal with this gas, you've already lost. So look, if you remember only one thing about the bloom, please let it be this. Forget about how it looks. It is a non-negotiable chemical requirement. You are neutralizing that CO2 barrier so that the real extraction can actually begin on a level playing field. So how do you do it right? It's actually super simple. First, you're going to use about twice as much water as you have coffee. So for 20 grams of coffee, use 40 grams of water. Next, just pour it gently to wet everything and then stop. That's the important part. Finally, you just wait. Give it a good 30 to 45 seconds to let all that gas escape and get the coffee bed ready for a perfect extraction. Okay, so the coffee bed is degassed, it's stable, and now you are ready for the main pour. This is where we take everything we've learned about those four forces and apply it so we can move from chaotic pouring to precise, controlled extraction. And this is the dilemma you're facing. If you pour way too aggressively, you create all that turbulence we talked about, destroying the coffee bed and making channels. The water just flows right past the grounds. But if you're too gentle, the grounds can clump up, which leads to an equally inconsistent and probably sour brew. The goal is that perfect middle ground. The best way I know to get this kind of control is with something called a pulsing pour. So instead of one long, continuous pour after the bloom, you do it in stages, or pulses. This technique lets you keep a really consistent water level, it controls the turbulence, and it prevents those dreaded channels from forming, which all leads to a steady, even percolation. All right, let's bring this all home. We've talked about the forces, the goals, and the techniques. Now, let's build the final formula, the scientific recipe that puts all these principles into one clear, actionable plan. And here it is. This is your cheat sheet, the formula for a perfect pour-over. You want a 1 to 15 or 1 to 16 ratio of coffee to water. That's for strength. Get your water right at 93 degrees Celsius for that perfect balance. Aim for a total brew time of about 3 to 3.5 minutes. And hey, pay close attention to that drawdown. The last 30 to 60 seconds of the brew will tell you if your grind was right and if you had any clogging. So there you have it, the physics of a perfect pour-over. You've got the formula, you've got the variables, you know the techniques. But true mastery? Well, that comes from understanding not just what to do, but why you're doing it. So the only question left is, what are you going to brew tomorrow?